Okay,
Go ahead.
great. So yeah, similar to our first speaker, I'm thinking about collective intelligence, specifically within the realm of collaborative forecasting. So the title of our talk today is Improving the Accuracy of Collaborative Probabilistic Forecasts with Slider Swarms. My name is Gregg Willcox, and I work at Unanimous AI with Colin, Domnauer, and Melissa Rosenberg. So this works. Great. So I'm going to talk through today what artificial swarm intelligence is, some of the research that we've done on human swarm intelligence, specifically talking about a new technology that we've developed called slider swarms to elicit accurate group probabilistic forecasts in synchronous environments. So if you're in a meeting with everyone, how do you generate a probabilistic forecast that is accurate? And specifically how we tested this in a controlled environment. And then 3 real-world forecasting tasks. So yeah, at a high level, artificial swarm intelligence is the process of connecting humans with knowledge, wisdom, insights, and intuitions with algorithms in real time to form artificial experts that can create more accurate predictions, decisions, evaluations, and forecasts. Rather than relying on big data with machine learning, as many of you folks know, we are humans have a lot of intuition in the real world that we can tap into, and so ultimately we've designed this system. And artificial swarm intelligence in general goes back to natural swarms, so birds and the bees and fish and ants. They're these really beautiful structures in nature, swarms that are systematic. They evolve as through the interactions of individuals rather than a top-down process, and this is swarm intelligence. So at a high level, the question is, how does nature do this? How does it evolve methods for amplifying the intelligence of groups? And it doesn't run polls, surveys, or focus groups or analyze big historical data sets. It forms systems, and these systems are real-time systems that allow the group to think together and converge on optimal solutions. And the group is smarter together than they are alone. So we took this background and wondered, can human swarms, specifically, can we develop a technology that allows human groups to benefit from the same processes? And this is the technology that we've developed that allows human groups to do this. So at a high level, the technology is composed of 2 components: a swarm interface, front-end client, and an AI engine and back-end client. You can see the front-end client here. So this is a group of about 35 people working together to forecast the Oscars in 2019. And it's a real-time system, so everyone's there thinking together. And there's 6 options appear on the side of the screen, and the group deliberates. Each user has a magnet. Your cursor turns into a magnet, and it pulls on the puck. So you can use your cursor to pull on the puck, and you can see each user represented as a magnet here, deliberating in real time between the alternatives. The puck's location is determined by not just a weighted sum of the individuals, but actually there's a little bit more detail here, but ultimately it's a discussion it's a deliberation between the individuals on the front end and an AI system on the back end, where the AI is a set of rules that determine where how much to weight each user based on how much conviction they're showing, what their behaviors are, and ultimately move the puck towards an answer. So at a high level, we've shown that this type of system allows groups to reach significantly more accurate forecasts. So we worked with Stanford Medical School and saw a 33% error reduction when forecasting pneumonia, the presence of pneumonia in X-rays with radiologists. On the subjective judgment of business teams, we saw similar 52% improvement compared to individuals, and then a significant improvement over a vote, as compared to a wisdom of the crowd approach. And this was basically like an emotional intelligence test, or identifying the mind in the eyes is the name of it, identifying the emotion in a set of images. It's similar with financial traders working in collaboration with Oxford University. We saw a 26% improvement as compared to individuals, and a similar improvement with respect to the crowd. In forecasting the direction that these crude, oil, gold, and SPX would move in like a 48-hour interval. So we've done many of these studies, and we know that this interface allows groups to reach significantly more accurate decisions. Our goal, our next step was really to say, okay, we know that, like, how do we create more accurate probabilistic forecasts? This technology at the moment is really good for reaching binary decisions, but we want to improve it and refine it for collecting probabilistic forecasting data and allowing groups to forecast probabilistically more accurately. So we designed a new interface called Slider Swarm. The motivation here is really more accurate probabilistic forecasting and collecting more behavioral data on individual probabilistic forecasts. The system works as a two-phase approach. First, individuals deliberate without seeing anyone else, and then we show the group results and allow the group 25 seconds to update their opinions. And so I'll show you a video of this process happening here. This is sped up 3 times, but where we see an individual here responding to forecasting a baseball game, and first giving an opinion, and then a probabilistic forecast, and then working with the group to refine a probabilistic forecast, and ultimately create a collective probabilistic forecast in real time to forecast the outcome of this game. Yeah. And this system takes less than a minute, right? So it's a very quick method for generating what we hope to be accurate probabilistic forecasts, or at least collecting the probabilistic data from many people. Cool. So this is the system at a high level that we built, and now we wanted to test it and understand how does it work and when does it work. So we designed a controlled environment where we can control essentially the confidence and of each user in a system. So we really wanted to understand, does the system work overall for probabilistic forecasting, and does it work when there's a confident majority and a confident minority? Because ultimately, if you're able to have a probabilistic forecasting system work when there's a minority that's confident, that's really powerful. It allows you to shift, it allows you to do significantly better than a vote, right? Which would just always show the majority's opinion. So in this simulation, in this situation, we showed groups of users, generally about 20 to 30 users, a simulated bag of 19 marbles, and we created a simulation software to show each user a different random sample of marbles from the bag, and we asked all users to predict the probability the bag contains majority blue versus red marbles. So here's this interface, and you can see these are 2 views of different users in this interface. They both saw a set of marbles, but one saw 6, 5 red, 1 blue, and one saw 7, 3 red and 4 blue. So one was weakly confident. So the top one is strongly confident that red is correct, and the bottom one is weakly confident that blue is correct. And by showing different number of users, these 2 views of the problem, we can control the confidence and the size of the groups. So this technology, this simulation basically allows us to have very tight control over the expected confidence of users in the group and the composition of the group. And we changed the useful knowledge that each user sees by varying the composition of marbles. When we got the group together to forecast this, whether the bag contains more red or blue marbles, we saw significant reductions in error compared to the individuals. So the Slider Swarm created more accurate probabilistic forecasts than the individuals, as measured as in a survey. The wisdom of the crowd, which is really just a survey, like the mean of all individual surveys in this context. And so we saw a 10% reduction compared to the wisdom of the crowd, and a 20% reduction compared to the individual. So at a high level, what we're seeing here is that the groups are able to make more accurate probabilistic forecasts using slider swarm than taking a vote ab initio. And by the way, compared to the first talk today, we're not applying any other, we're not weighting in any other way other than allowing the behaviors of the individuals in the group in this software. So we don't consider expertise, we don't consider any of these other strategies. Our goal is really just to amplify the intelligence of, basically to amplify the probabilistic forecasting accuracy of the group using these simple behavioral methods and technologies. So at a high level, this worked. We looked at 3 real-world forecasts to validate that this actually works in the real world, including, again, an emotional intelligence test, trying to identify whether images are real or photoshopped, and then forecasting the Academy Awards. At a high level, because I'm running a little low on time, I will jump through this and say, at a high level, we saw, again, a significant reduction in error using this interface as compared to the survey, which is a wisdom of the crowd, and individuals. And at a high level, it was 11% more accurate versus the simple survey, which is a meaningful and statistically significant reduction. So the question is sort of, when does it work and why does it work? We're able to show with the Marvel study that it works both in cases where the majority is correct and where the minority is correct, and it increases forecasting accuracy in both cases. So it's not just amplifying the majority opinion. The group forecasts improve even when there's a confident minority, is what this should say. So even when there's a confident minority, the group tends towards that confident minority more than the simple mean would suggest. And so this goes to, why does it work? The key difference as compared to collection or aggregation of forecasts in a survey is that we're seeing individuals behave in real time, and we're creating situations where they're exposed to the beliefs and behaviors of others, not just reporting a static confidence value. We're not collecting data from individuals and aggregating them. What we're doing is we're creating a system where they behave together in real time to forecast an event. And so they're weighting their individual conviction, their confidence, and behaving in ways that reveal this confidence. We're tapping into the emotions of the group, right? And so what this really means is that if someone is not confident, they're more likely to switch answers than if they are confident. Yeah, so at a high level, this is why the system works, right? So for groups that were confident in the Marble study, they moved significantly less than groups that were flexible. So the groups that had a lower confidence, that were initialized to have lower confidence, simply moved more. They acquiesced to the more confident people more than other users, right? And this is at the core why the system works. It's because people are interacting in real time and weighing their own feelings about whether they're correct or not. Yeah. Let's see, I'm at 1351. Okay, I'll mention this, which is just if we took a vote, right, rather than calculating a mean probability, if we took a vote just saying, what is this bag of marbles, red or blue in this study, and taking the majority opinion, we would have only gotten one of the questions correct in the personal deliberation phase, so without any group interaction. When we interact with the group, we jump all the way up to 15 correct, which is 56% accurate. So the process of interacting with a group is really important here. But again, once we take the mean of those answers, rather than just voting, we get up to 17% correct in binary accuracy. So the majority of this improvement is coming from individuals interacting, and then like a fraction of the improvement is coming from taking the mean answer. Anyway, that's the deal. That's our study. We showed that slider swarms allow groups to create significantly better forecasts than surveys or the wisdom of the crowd. This effect holds when the minority is correct, and it works because the less confident users are more likely to concede to the group than the more confident users. At a high level, we believe that this technology, along with the standard swarm technology, which we've published a number of papers on, may be an effective tool for real-world collaborative probabilistic forecasting. And this is like really one of the first studies that we've we've published on this new interface. That wraps up, and yeah, we're really interested in collaborating and learning from people in this conference. So any questions you have, would love to hear and to engage with.